All right, everybody, thanks for tuning into the Daily Space Weather. I'm your host, Dan, aka smAsho. We'll be talking coronal mass ejection analysis. We see a LASCO halo, and we'll even give a mention to Sagittarius A star. First, we'll look at our local yellow dwarf. And what we're looking at here is a composite of the 335, 193, and 94 angstroms wavelengths from the SDO. And you can see this long-lived solar flare accompanied by a coronal mass ejection. The peak flux happened there, peak X-ray flux happened at about 1630 Universal Time yesterday. So there's the X-ray flare happening in 3 different wavelengths. Radio flux, the 10.7 centimeter radio flux is at 90. There's the 1-year chart of that. And for you new viewers out there, thanks for tuning in. The radio flux is a good proxy for sunspot number, especially useful at time of solar minimum. Notice how proportional the radio flux is to the sunspot number. So we see a dip in the radio flux at the same time we see lower sunspots. So now, this is what we call a halo coronal mass ejection. When you see the coronal mass ejection on all sides of the sun, that could be an indication that it is Earth-facing. Now, this is Mercury over here, by the way. You can see that this coronal mass ejection appears all around the coronagraph disk, the obscurement disk here in the middle. And it's not necessarily an indication that it's Earth-facing, but this one is. So what you're looking at there is the LASCO C2, which is part of the SOHO, which is located here at Lagrange point 1. To really figure out whether it's Earth-facing, you have to look at Lagrange point 5, also stereo A. So we've included that as well. And there's the stereo A coronagraph. So you can see that is a pretty perfectly Earth-facing coronal mass ejection. And the forecast from NASA and NOAA is that some of that will miss to the east. Here is the Enlil spiral of that. And the forecast there for the coronal mass ejection actually to miss to the west is the main density of that. And the top frame there is the density. Bottom frame is velocity. The forecast for impact is looks like late in the day, actually early in the day tomorrow. So it looks pretty high speed here, surprisingly. And we could see additional coronal mass ejection events. We'll get to that before the end of the video. This initial strike here, this is actually a coronal hole wind stream, and this here is the coronal mass ejection. And so we could have 2 different interacting situations there. The coronal hole wind stream, high velocity wind striking at the same time as the coronal mass ejection shows up. We're not expecting a super hard strike from this. We could see a geomagnetic storm. We'll let that play through again. And since we are streaming this video live, after this I'll take a quick look at the stream and the chat. Leave us a comment with your stance. And even if you're not viewing live, we read all of your comments. So thanks everybody who's left some. We've got some great Helio Viewer movies today also. Here's one of them. This is 304 angstroms and 335 angstroms composite. And that's what gives it that purple color. By the way, if you didn't see it last night, we did a video before the coronal mass ejection was totally done propagating. Solar flare / coronal mass ejection, the sun, 1630 universal time. So if you haven't checked that out, go have a view of that. And we put a bunch of close-ups of the solar flare activity on there as well. There it is in 171 angstroms. And we're going to show you more HelioViewer movies toward the end of the video. First, we've got to blast through a whole bunch more data. So let's get to that. First, I would recommend everybody check us out on social media. We're on Facebook, Twitter, Gab. We've got a Facebook group called Entropy Busters. There's the homepage of Entropy Busters. Also on Twitter. And we've got exclusive content on all of those sites. So check that out if you haven't. We would also like to announce that we'll be streaming live at the moment of the solstice, which will happen Monday, December 21st at 5:02 and 20 seconds Allentown time. So join us there. We wish to be the first channel to wish you a happy solstice. And if you enjoy the content on YouTube, press like and subscribe over there. Thanks to our new subscribers. Don't forget to share on your social media. Tell your friends, foes, your science noobs, and your science pros. We're also on BitChute. There's some exclusive content there. And again, we are streaming live to Twitch. It's twitch.tv/smAsho. We don't always stream live. And thanks to our new followers over on Twitch. Also, check out our own servers, smashomash.com. You can link to all of our social media there in the upper right corner. You can also link to the stores and the forum. And today's featured product is the I Survived a Global Pandemic So Far shirt. Perhaps pick up one of those. And don't forget to enter the promo code smAsho on all orders through Christmas at checkout and save 10% on all of those orders. It's the official store of the Smash News Network. We're going to talk very briefly about cosmology today. We won't be talking about anything random. We'll be talking about something very far away. It's Sagittarius A star. There it is on the 2 mass, which is infrared spectrum, by the way. Right at the core of the galaxy. The core of the galaxy is called Sagittarius A star. That's how it's pronounced, SGR space A asterisk. And here it is on Chandra. Zooming way, way in to the X-ray emissions. That's actually S1 and S2 you see there, very close to the galactic core. The core of the Milky Way galaxy, Sagittarius A star, the featured object on today's cosmology segment. Let's get into more data here, such as the real-time solar wind. We see a small ramp up here in the solar wind density, still at pretty backgroundish levels there. 3.69 protons per cubic centimeter, solar wind speed 352 kilometers per second. The KP index, a measurement of global magnetism, is at 2 right now. Here's a visualization of the magnetosphere. It's 4 hours of magnetohydrodynamic pressure, courtesy University of Michigan. Nothing too exciting happening there yet. And the coronal hole wind stream is showing up a little later than I anticipated. I would expect the arrival of that higher density from the coronal hole wind stream at any moment, really. And here are the ground magnetic perturbations, and we see significant perturbations here, both over Antarctica as well as both North Poles, and since that refreshed, we'll let that play through. What you're looking at there are changes in the Earth's B field, and the B field is the field that goes through a magnet. Some significant perturbations there. I would note that the South Pole, the South Geomagnetic Pole that is somewhere down here. The North Geomagnetic Pole is here, but we also have a pole over this is the net pole in the north. We also have a Siberian and a Canadian North Pole. And we see significant changes in the fields on both of those. But really, this is the point that I find the most interesting, because while the south geomagnetic pole is over here, how come so many perturbations on the other side of Antarctica? We see the protons are back here. So we saw the protons subside here, associated with the last coronal mass ejection that struck the Earth's magnetosphere. And we see some are back already. So not that surprising, as some of the ejecta from a coronal mass ejection can be moving as fast as about 1/4 of light speed. So we see some protons here already, and we see this long-lasting solar flare. So remember, folks, coronal mass ejections are protons, solar flares are photons. Protons, photons, don't get them confused. And you can see that solar flare started at about 1540 universal time, and it's really just ending now. So the C portion range ended at about, the C-class portion ended at about 1930 universal time last night. Here's a star chart real quick. We won't pay too much attention to that at in-the-sky.org. Here's where stuff is in the solar system. There's where things will be in a week. Looks like new moon will fall on the 15th. And everybody's gearing up to go view Jupiter and Saturn when they'll conjoin in our sky, although not in relation to each other or the sun. GOES magnetometer is the next frame. And I believe we've crossed into the other current sheet. We'll show you in the next frame. Here's a visualization of the current sheet polarity. South pole shown in red, North pole shown in green. Keep in mind the data is nearly 2 hours old. I think we've already crossed into the North Pole current sheet there. So most of the activity on the sun right now is in the southern hemisphere. And the south solar polar field showing some signs of strength. Here's a line of sight coronal hole field plot. And this shows you the sun's B field in blue. It shows you south pole oriented coronal holes in red and north pole oriented coronal holes in green. And the coronal hole wind stream that is just about here is a south pole oriented coronal hole. Here's another view of the line of sight field plot, which also shows the solar magnetogram. This data is derived from 51 ground-based magnetometers. It's part of the National Sunspot Observatory, as well as magnetometers on stereo A and stereo B. Now we're going to go back out to Lagrange point 1 and Lagrange point 5. I just wanted to show you here from stereo A, here's the still image just before 8 o'clock universal time, and you can see there still is a whole bunch of plasma out here in the corona, which is why we could see additional coronal mass ejections. That's a real solar forecast. It's part of the point of our channel. And so there you have that. Don't be surprised to see additional coronal mass ejections in the next day or two. You probably heard it here first. Again, don't forget to tell your friends, foes, science noobs, and science pros to subscribe, press like, press notification bell over on YouTube, youtube.com/smashomash. Visit our sites. Consider becoming a patron at patreon.com/smashomash. And last but not least, we're going to look at, in terms of magnetic field plots. Here's the magnetic field of the solar corona. And you can see it's looking quite chaotic here. Closed potential field force lines shown in pink. And let's move on to talk about electrons. We don't see a lot of surface charging here. A little bit over places like Mexico and Central America. Here's a 1-year chart of the electron flux. That is from solon.info if you want to monitor that yourself. And I would concur with this forecast now, forecasting a downtick in electrons from current levels. And here's a 3-day chart measured at the F2 ionosphere layer by the GOES 16. Here's a visualization of the entire air column. It gives you an idea what your GPS errors may look like. And the higher the level you see here, the closer to red that is, the more GPS error you'll get. Keep in mind this is a forecast and a model. And we do see some anomalies here over mainly North America and Canada. Nothing major. Some minor ones over Antarctica there. There's probably nobody there. So here's just a diagram of the Van Allen belts and the location of spacecraft such as the SDO, the International Space Station, and GPS satellites. And here's another diagram. And if you see that F on the right side, that's the F layer of the ionosphere where the GOES endeavors to make its measurements. We see some absorption happening here in the polar regions as the protons are back. So you're going to see some absorption here at the 1 decibel bandwidth. Let's just advance this manually. There you can see that is a result of the protons showing up again. The protons are back. And we're expecting a larger uptick when that coronal mass ejection strikes. There you can see some signal absorption at 1 decibel around the poles. Next we'll look at just the ionosphere layer. I thought I already loaded that. Here at the Smash News Network we do tend to stream live, and that's the dangers of streaming live. I like it. I think it's compact. So here's a 1-day visualization of the ionosphere courtesy of Australian Government Bureau of Meteorology, and it's looking a little anomalous to me here. It's a little bit charged up in the northern portion. And we're seeing sudden charge ups and charge downs around the equatorial regions as well. Here's the latest image. That one came in at 9 o'clock Universal Time. Let's do a rundown of volcanoes here at Volcano Discovery. Kluchovskoye is erupting, 20,000 foot ash plume there. Abiko, flight level 120, 12,000 foot ash plume. 4,000 foot ash plume at Sakurajima. Suwanosejima also, similar size ash plume there. Dakono's exploding, 7,000 foot ash plume there. And a powerful explosion occurred at 8:08 local time yesterday at Popocatépetl, down near Mexico City. Fuego, volcanic ash not seen in satellite and webcam. Please don't attempt to tightrope the caldera. It could still be erupting. It could be obscured by clouds. Sangay is exploding. 21,000 foot ash plume there. No volcanic ash cloud observed over Revenador. Sabancaya is exploding. 27,000 foot ash plume there. And the effusive eruption at Piton de la Fournaise on the island of Réunion has stopped. Don't be surprised if that resumes. And Barren Island in the Indian Ocean, there's a new one on the list, producing a 6,000 foot ash plume as it explodes. Barren Island. First time I think we've covered that one. Next we'll look at earthquakes, and it looks like a small uptick here in earthquakes. We saw a deep earthquake event happening yesterday when we reported on it, and we see continued deep earthquakes now, such as this 4.8 near Fiji at over 600 kilometers depth. And only a half an hour later, 32 minutes later, we see a 4.4 at Argentina at depth. A few hours later, we see a deep quake at Vanuatu. So we see nothing over a 6 magnitude. One of the largest was this 5.4 at the Philippines. And we'll just scroll up the list here. Just scrolling. Here's a very shallow quake at Hawaii. Once again, we've seen an uptick here of high altitude quakes under Mauna Loa. So there's another magmatic quake for you there. That one happening at 1,700 meters above sea level. Another shallow quake at 1,500 meters above sea level. Here's a deep one at Peru. It's a 4.1 magnitude at 126 kilometers. So once again, if you're in an earthquake-prone zone, such as these areas, have a plan, because we're seeing a drought in 7, 8, and 9 magnitude quakes. Those areas especially. Have a bug out bag. Know what happens when the power goes out. Don't be in a building that'll get looted. Here's what's going on windy.com's pressure maps. And we're going to advance this in the GFS forecast into tomorrow. I'll rock it back and forth. There's 12 noon my time. Powerful low pressure system there south of Greenland. The southern portion of Greenland actually surrounded by 3 low pressures, as well as one moving around the Aleutian Islands there. The low pressure system in southern Alaska looks like it's going to break down. Powerful high pressure system there over central eastern Europe, actually. Looks like a pretty major anticyclone there. And that's the GFS forecast, courtesy windy.com. They've got a great mobile app. Perhaps consider downloading that. I'm not paid to say it. And check out the backwards jet stream happening here over the Great Salt Lake. Jet stream blowing east to west there. Not the normal flow of things. We still do see this precipitous split, sending cold air into the southern Atlantic and hot air toward Iceland. Jet stream splitting right in half there over the central Atlantic. Excuse me. So those are the jet streams of the western world. Here are the jet streams of the eastern world. A little bit more coherent on that side of the planet. Let's see where lightning's striking here at lightningmaps.org. Quite a bit of lightning. No terrestrial lightning in the US. Here's the NASA GOES lightning mapper. Some pretty serious band of lightning there south of Bermuda, as well as northwest of it. Next is the US Doppler Radar Map, one of our value-added services. Snow showers over Pennsylvania, as well as some significant snow there over West Virginia. Mainly only just showers besides some steady rain over northwestern Washington. Here's what's going on in the cloud layer. And we use the NASA GOES Interactive Weather Satellite Shortwave Radiation Map. I believe it's 3.2 nanometers. As water emits radiation. It's a guess, a model of where the clouds will be. I would note low clouds, significant low clouds over the Gulf of Mexico and the Atlantic once again. And here's the water vapor map. We'll rock it back. There's the cloud layer. Water vapor. And the water vapor map is useful for you new viewers. The water vapor is useful when the Doppler radar does not tell you what's going on. And we're seeing some cold air being shoved down there over Minnesota and Iowa. In fact, the entire north central portion of the country seeing cold air being sent down from central Canada. No need to zoom in today, just to remind our viewers to stay tuned as we've got bonus features. The rest of our HelioViewer movies, a high-res colorized magnetogram, and the intensitygram, because we're going to look at the only sunspot group. There it is in colorized magnetogram. And there's the full disk view. Only one sunspot group right now. And there it is. There's a close-up. It looks like some activity could be going on right now. Also a little bit of a decay, a slow decay of that sunspot. And last but not least, we'll show you the rest of our HelioViewer movies. We've put up a couple more composites here. And this one is the 171 and 131 angstroms. And these are both good at showing magnetic looping of ionized iron spectra. It's a bunch of hot iron plasma. And we'll continue doing more and more varied content here as solar activity ramps up. It's part of a 5-year plan at smAsho.com. Again, please visit our links, consider supporting the channel, becoming a patron, etc. Here's another composite view. It's 94 and 193 angstroms. And the coronal holes in the north have actually grown there. This is actually a view from last night. This is 94 angstroms. A great view of that solar flare. And 94 angstroms actually takes more images than all the other wavelengths except for 131. 94 and 131 are specifically done that way in order to study solar flares. Again, the peak of that solar flare yesterday was at about 1630. Next, I'd like to thank our patrons. Consider becoming a patron at patreon.com. Our patrons are the true source of funding, as we're paid approximately nothing on YouTube through Google AdSense for these videos. So again, please share on your social media, etc. Thanks again to our patrons. And here's the final segment of the video. It's the 171 angstroms close-up of the southern hemisphere. Again, there still is significant possibility of more coronal mass ejections. Allow me to get off screen. Thanks again for tuning in. Welcome to the Neo-Renaissance. And may that solar wind be at your back.